This is Jim Helsper, CORTAC Group. We're going to talk about a topic that is near and dear to my heart today, risk management in the winning proposal. This is part of the CORTAC training system. We have sets of charts that we go out with materials to brief our clients and help them develop the winning proposals. This is a shortened version of a set of charts that we do about risk management, and I'm just going to be touching on the highlights today. The objectives of risk management in a winning proposal is defining exactly what our risk management approach should be, where it is addressed in the proposal, how are we going to organize and present these risks, what makes a good proposal risk mitigation approach, and finally, what are the types of risks and how should they be addressed in the proposal and where. So with that, we're going to talk about the CORTAC 4 elements of a winning proposal. We like to keep it simple. We like to keep it down to 4 or 5 items. In this particular case, we have the big 4. You got to be compliant, follow instructions, answer all the questions. For those of you that were in a past webinar, we talked about hyper-compliance. That presentation was specifically directed at this topic. One of the many areas that we talk about compliance and how we're going to comply. Hyper-compliance is just one of the things that we use. Scores well, written evaluation criteria. The preceding webinar addressed that particular area where we talk about the facts and data that clearly show how we meet and in many cases exceed, go to blue, on those scores. The third area is demonstrate low proposal risk. Typically, this involves a lot of horizontal integration across all of the volumes, make sure that there are no inconsistencies, but also very important in this is have you acknowledged the risks inherent in your offer, and do you have a mitigation plan in place for each one of those in order to mitigate them to low. The fourth element is the compelling offer. Our next webinar will be talking about a topic that deals with a compelling offer. Right now we're going to talk about program and proposal risk. Now, I've been invited to many red teams. I look at the proposal, and since risk management is one of my favorite topics, I usually gravitate to that right away. And usually what I find in a proposal is that I'll at a minimum have a risk management process. That is that you identify, assess, monitor, blah, 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 all the elements of risk once you've how you identify it, how you mitigate it, etc. So they'll talk about that process. Sometimes it is in a risk management plan, sometimes it's in the management volume, sometimes it's in the mission capability volume. The second thing they always have is a risk management tool, okay? And usually this risk management tool is mandated by the customer who says, I want all risks reported in this. This is particularly true when you're in a large system and you're only bidding on a part of it, and the government is sitting at the top as an integrator, and they have to be able to integrate all of these products across the spectrum in order to develop the capability that they want. If they have a single risk management tool, they would like all of the contractors to use that tool so that they integrates well and reports up and rolls up. Many of these are new software tools, and some of them are very powerful in that some of them will integrate cost, schedule, and technical information so that you get a good idea of where you are in a mitigation. Fourth element of most proposals is they have a risk list. Some of them are very short, 10, maybe even less. Some of them are long. I've seen proposals come in with as many as 25 risks. Some have been in place a long time, and the others are collated at the last minute because we had to have a risk list. The fourth element, of course, is usually some program management statement of how important risk management is, either to the program, the company, or what have you, and we start talking about things like it's part of our culture, it's our best practice, etc., all of which try to convey an element of importance of risk management. However, I find that it's very difficult to score blue with that. In many cases, that is the minimum that you really need to have, and in most cases that will score something like a yellow, maybe even a green. But in today's world, where we're shooting for blue or falling back to purple in cases where we can't make it, greens and yellows don't make it. We need to go to blue. So we talk about a risk management approach. In our last webinar, we talked a lot about how we deal with the word approach in section M. When the government asks for approach, We have a standard methodology to respond to that. In this case, if they ask for your risk management approach, we apply the same methodology where we have 3 elements. The top-level methodology, which is a combination of process, tools, and how you really deal with the risk on your program, including how you assessed it and how you ranked it. Number 2 is organization. One part of risk is who does what on the program. Is there a risk manager? Where does that risk manager reside? The second is how risks are organized. Believe it or not, risks should be organized in some kind of coherent fashion that's easy to understand and convey to the customer. Coming in with a list of 25 items and having absolutely no order or rhyme or reason to them is very difficult to understand. When risks are organized into categories or classes or what have you, it's typically easier to convey to the customer how you're dealing with these kinds of things. The third element is the timing of the major activities. When will these risks go green or mitigated to low? What if you have a high risk element and things don't get better? Do you have a fallback strategy? And when do you activate that fallback strategy in case the risk goes red and stays that way? All of these 3 things you need to ask yourself and answer when you're talking about what is your risk management approach. So let's talk about the risk management methodology, right? Step 1 of the approach is the methodology. What do you do with a single risk? These are all standard things. We monitor it. Why do we monitor it? Well, it's low risk today, and we're only really going to worry about it if things go really terribly wrong. Number 2, we mitigate it. Yes, it's moderate risk or maybe even high risk. So we come up with a series of steps, and we describe when they occur so that we mitigate this risk to low. Sometimes we have an off-ramp. If a mitigation is unsuccessful, what is that fallback strategy? Number 4 is avoid. And I'd like for everyone to pay attention to avoid because this is probably the most important for our proposal. And one of the reasons is you could make strategic decisions when you decide what your offer is that avoids a risk that you believe your competitor has. We'll get into a little bit later on, but this is a very important thing. Except there's not much we can do about the risk. We know it's there. We'll monitor it. But we've made a decision to accept it as is. The 6th area is you can shift risk. We think this is the government's problem. Many crypto programs are run from a different agency in the government. That agency is responsible for developing those cryptological algorithms as well as the hardware and software instantiations that implement that crypto. Since we're the end users of that crypto, we don't need it. It's not we don't need it. We're not responsible for it. So in this particular case, the development and delivery to the contractor of a crypto device is the government's problem and not ours. Key to all of this is convincing the evaluator we have the low risk approach. So as you go through all of these things, you're going to sit there and figure out which one applies to which risk you've got. So let's talk a little bit about risk. First of all, monitor. Do you monitor all risks? Many risks are assessed low. As an example, weight. We may have plenty of weight margin right now, but weight is an excellent example in almost all programs, whether it be vehicles, aircraft, or satellites, where you must meet some kind of a weight requirement in order to be able to be successful. We all carry some kind of margin to it, but we monitor that margin. And as we use the margin up, we will track it against a profile so that we do not fall into an area that is now high risk. If we have insufficient weight margin, then maybe we ought to think that it should be assessed at a higher risk. So we should monitor anything in the proposal that is assessed green. Even if a low risk item can get out of control, we should monitor it. But for what? So in the case of the weight, we give them a profile of the weight margin, and if we consume 10% of the weight margin or 50% of the weight margin by CDR, we say that that's okay. If we consume more, then that is an area where we have exceeded the monitoring limits and we would do something about it. In that case, we may shift it to yellow. We may have to then assign a risk owner, and then we have to go back and report on the mitigation on a regular basis. So we always want to make sure that we have some kind of criteria, some kind of parameter, something that would indicate when that green risk is shifting to a yellow or a red. And that's why we monitor them. But these should be defined. Mitigations and off-ramps. What are we doing to mitigate risk? Typically, we spend money. We're going to do something. So we need budget to be allocated. It's got to be found in the WBS, and when you go over and look at the cost volume, you should be able to find that we're spending some money on some particular thing associated with a risk mitigation effort. We're going to do work. There are tasks that are going to have to be accomplished, whether it is working on this, developing that, whatever it is, there's going to be something that's associated with that risk mitigation in the schedule. Then you've got to talk about how you mitigate it. Once again, I talk about the standard Rubik's Cube, the 5x5 cube with red, yellow, and green. And when we make a risk assessment, the two axes of the cube are consequence and likelihood. And when we make those assessments, we can plot where the risk is in that cube, and we determine whether it's high, moderate, or low risk. So once we plot it on that Rubik's Cube, you have to figure out which way we're going to go. Are we mitigating likelihood, or are we mitigating consequence? And how you do this and what you do should be described in the mission capability volume or the other volume that talks about risk, whether it's a technical, management, or what have you. All high risks require some kind of off-ramp strategy. If it's rated high, the likelihood of it happening and the consequence of its happening is tremendous. So therefore, we have to be able to find an off-ramp strategy with decision gates and criteria that tell us when and how to implement it. Funding and effort is needed to protect that fallback. So if we're going after a very ambitious battery technology to save weight, we have to figure out what would happen if that battery technology isn't ready by the time we're ready to go through CDR, or later on in the program if we accept more risk. But somewhere, if there is an alternative, an off-ramp, we need to make sure that that off-ramp is still a viable off-ramp. So somehow we're going to have to sit there and spend money, whether it's design effort or whatever, to sit there and say, yes, we're compatible with the lower technology batteries, we back off on the power, whatever we're going to do, or we're going to carry more batteries and chew up weight, whatever it is, we have to come up with a fallback and make sure that our high risks can be mitigated through an alternate strategy. Avoiding risk. What are the clever things when we came up with our offer that avoids high-risk technologies or solutions that may impact costs and schedule? Did you have to develop a transmission, or are you using an off-the-shelf transmission? If we're developing a transmission, is there an alternative there? We want to avoid the pitfalls our incumbent competitor will likely have. If we're not the incumbent, we can ghost the incumbent and look at all the problems they had on their program and say, hey, look, we avoid that risk by not using that technology. If they had lithium-ion battery technology problems, then we go back to some other technology and we say we avoid that risk. The other area you want to avoid is areas where your customer had risk and problems. So if the customer had some kind of integration problem or they had schedule problems or something like that, you may want to come up with a strategy and a risk mitigation that helps them avoid that risk. So you may do a pathfinder that pathfinds the integration early, or you may give them engineering models early in the program to help them do an integration as an example. And of course, there's our own problems that we had on the last job, because after all, we have some kind of past performance. And if we had any of these problems, we got to be sure that, well, we didn't go to those guys anymore, that subcontractor, we learned our lesson, we're going to avoid that risk by not using that subcontractor as a good example of avoiding the problem that we might have had on the last job. And then you architect your offer, your program, to highlight our approach to avoiding those risks. Example, if this integration is a major issue, we may have gone in and added an event after CDR to demonstrate issues discovered during EMD tests that were corrected prior to LRIP award. So here's a case where we went through some testing, we did the integration, and we identified the fixes in it, and we went in and I added an event to review and make sure that those fixes actually fixed the problem before the LRIP contract was awarded. Avoiding a critical risk can be a major competitive ghost here, and that's where we ought to sit there and spend a lot of time in figuring out how we could ghost our competitors. There's excellent examples of this in past procurements that can be discussed. Program risk responsibility. So now we get to who does what on the program. First one needs to define the program organization, a very difficult thing, especially when you're talking about a customer-facing organization. Program organizations have competing interests. One is an internal, the other one is an external. The customer wants to see something and how they map into their program organization. And in the case of risk, they want to know how they're going to have access to risk, who's the point for risk, who's this, that, and the other thing for risk. And it's nice to have that all spelled out in the organization chart and an organization discussion. Then, once you define that, where do these all fit in? Where do the risk management activities? Who is the authority on accepting and approving the risk rating and the mitigation approach? Is there an independent assessment? Is it done by voting? How are you going to sit there and arrive at the ratings that you came up with? And then when you have defined the mitigation approach and you project where that approach is going to take you through the Rubik's Cube, is that agreed to too? Are we mitigating likelihood or are we mitigating consequence? Does the risk manager report to the program management office? Maybe the risk manager reports to the system engineer or the chief engineer. Another question is, who owns the risks? Are risks owned by IPTs and therefore the lead owns them, or are they owned by an individual and that individual is responsible for reporting? Then, providing the technical status. And how is that technical status validated? Yes, we really did do this in the lab and we got 22 femtofarads. Who validates that we really got 22 femtofarads? And the second part of it is the cost and schedule status. How much money we spent, how long did it take, where do we think we were going to be at this date, and how much do we really think we were going to cost to get to this point? And how is that status validated? We need to have we need to have a clear assessment of where we are and how we're moving through the through the program as we mitigate these risks. And like all processes, when there is an interface between organization, how does that handoff occur? Just think, we had technical, cost, schedule, and then we report up through a risk manager up to the program office. All of these represent handoffs, and these handoffs have to be defined and how they occur and when they have to occur and who's responsible for making sure that the handoff was properly implemented. Program risk organization. The risk list, you'll see it, it's a compendium. Sometimes we put the high stuff at the top, and that's the rank order by risk exposure. But does that really tell you anything other than what's the highest risk? We like to present risk in an organized, to make a good story. We've identified in the past 3 areas or 3 ways you can organize risk. You can organize risk by type, the type of risk it is. You can organize by what is important to the customer. Typically, a customer will have KPPs or key performance parameters, or they'll have most important requirements that come out of the statement of objectives. And you could organize risks along those. These are the things that affect this requirement. These are the things that affect this objective. Or you could organize along block by. A lot of programs are developing in incremental blocks, like software programs will upgrade through the years by deploying various releases of software. When you organize by type, here's one way you can think about the types of risks. You could define the first type of risk as technology risk. Can you really get the 42 femtofarads out of this device? Usually, a technology risk needs to be mitigated to low by CDR. The corollary to this is the technology readiness level. Typically, the government's requirement now is that you can't go beyond CDR without having a TRL level 6 or higher. So the corollary here between technology risk and technology level is that really your technology risks, like any miracles that you have to make, technically must be mitigated to low by CDR. And that's only to be compliant with what the government wants in the first place. The second type of risk could be something like integration risk, right? We built all these separate components, subsystems, whatever they are, and they all have to be put together. When would you like to see this integration risk mitigated to low? Well, what you would really like to have is all of the integration risk mitigated to low prior to the final acceptance, integration, and test of the first delivered unit. In the space business, we had a saying: don't debug the hardware, don't debug the integration on flight hardware. Flight hardware was too precious to waste on a test that could damage the flight hardware. It is better to do all that integration risk mitigations with engineering models or qualification models before you get the first flight unit. The third type of risk is producibility risk. You can make one, you might even be able to make two, but how is that transition to production? Once again, there is another corollary with DoD instructions about manufacturing readiness levels. They define a whole set of things that have to happen before they determine that your manufacturing readiness is sufficient to enter a milestone C. So anything we identify as a producibility risk needs to be mitigated to low prior to milestone C. Okay. Typically, we put a lot of the reliability-related risks in the producibility. Can I make a reliable product? I've got to be able to have the right technology assembled the right way. This is a producibility thing. So those risks need to be mitigated by milestone C. The fourth type of risk could be operational risk. I mean, we're all smart engineers. We're working around in the lab. We know exactly how it works. But what happens when the folks in the services get it? All those operational things, such as the instructions and all the work orders and work instructions, have to be written, developed, tested, and proven that the services can operate this system, maintain this system to meet the requirements that it was originally intended to. So this is an example of operational risk. And training things and those training packages that you deliver, those are related to this operational risk. The final type is the catch-all programmatic risk. The point is I could carry a moderate or a high producibility risk well into the program, because if I make a statement that says I don't need to have this mitigated until milestone C, I can carry it through CDR, all these other things, and I don't have to worry, show mitigation to low until I get to that phase of the program where it must be mitigated to low. So this is an area where you can sit there and see, based on the type of risk, I can have various mitigations that happen at different points in the program according to when they're most appropriate. Organizing by customer need, this approach is very powerful, but it requires a lot of work. You've got to get engineering involved. You start with KPPs and then identify the risk associated with KPP. If you build a hierarchical risk plan that traces from the KPP, you can show the customer, hey, look, I've focused on this KPP. I got to make the KPP. Here's all the things that are associated with that, put that KPP at risk. Okay. You could also start with a statement of objective, and you can identify a most important requirement. And you can build a hierarchical risk plan that traces from that most important requirement. This may be something that you can do on a services program where the customer says, hey, the most important requirement here is timely service, delivery of service. And you can talk about, well, here's all the things that put timely delivery of service at risk. All of these things relate to that one type of requirement that they wanted. There will be only a few risks at the top level when you do this, since they focus on the things that are the most important to the customer. The customer can see how each risk achieves one of their objectives or one of their key parameters, and they can see the associated cost and schedule for each. So the power of this is it puts it into a customer-viewed framework on how they would view risk, which is, will I make my KPPs? Will I meet my objectives? So here's an example of what you might do. This is just made up. This is not something that I pulled out of a proposal, but I just use it as an example, mostly because it's about 4 decades old. The KPP requirement for the original M1A1 Abrams tank, way back when, one of the key things they were worried about was crew survivability. And at some point they might have said something to the effect that our tank must survive first round hit from any range, from some range, from any weapon. So somebody, systems engineering, would look at this and say, if crew survivability is the KPP, what could kill the crew. And they go through all the things that could kill the crew, and then they assess the risk of their current design meeting that, mitigating that possibility. So now you have everything folding out of a crew survivability requirement, and when you get down to the details, you find out that maybe one of the first sub-tier risks is that the armor, that you have to be able to withstand a 125 millimeter round from 2,000 meters. The second subtask would be the risk of ordnance deflagration from the shell fragments from that 125 millimeter round. And a third sub-tier risk might be that the fuel temperature achieves a flash point due to that round hitting something and starting a fire. So all of these relate back to that one requirement, which was crew survivability. And in doing this, you're sending a message that you recognize what is important. You've investigated all the possible risks that would put that requirement at risk. And now you've got a program in place to sit there and work through them as you march forward. Organizing risk by block buy. Back in the last 15 years, there were a lot of programs that were thinking about block buys. I mean, the F-16 is into, what, its 7th block now? More and more customers are being forced into the buying an incremental capability, and one of the best ways is through a block buy. We want to win the initial block, and of course all the subsequent blocks. The worst thing that can happen is you start off with a contract that says you're going to buy a whole block of things, and then you get canceled because you didn't mitigate some kind of a risk later on. So you plan the initial block with an acceptable risk. You also plan for risk mitigations for future buys. So when you lay out your block plan and say, I will do these requirements here, and then I will do this upgrade to meet those requirements in block 2, and then this set of requirements in block 3, you talk about the risk mitigations associated with each one of those and when they just have to happen. And you keep going out in the future, so you tell the customer that you actually have the big picture of how all these blocks are going to come together and all the risks are associated with each one. I've seen this one where we've combined elements of all three. We say we organize by type, and we call that the vertical approach. That's the contractor view. Technology issues were going to be resolved by CDR. This is our gated process. This is the contractor view of risk. Then we add a horizontal flavor, which is tied to the customer's most important requirements. System availability, reliability is a horizontal risk to be worked across all program phases. It touches many aspects of the program, and you can link the ones that you had in your vertical approach with the horizontal one. And then you add an off-ramp flavor to the future. You add an off-ramp to the future deployment. If XYZ does not make its initial risk mitigation goal, it will be considered by the risk board for deferral to a later date. And if the customer sits on the risk board, they have a say in it too. This shows that we systematically understand and manage the risks, and it's more than just a process discussion. The customer can actually see how you're going to manage it, as opposed to a process. Transposing risk from worries to tangible elements. This is how you have to write a risk into the proposal. Risk concerns, they got to be something that is tangible and actionable. You know, bad weather, earthquakes, acts of God, natural disasters, what have you. These are worries. We got to break these things down into what would be required to be incorporated in a risk. A good method to do this is to require statements, risk statements, that have three elements and are in this structured format. If, due to, then. If this risk can happen due to what causes the problem, then the consequence of the risk occurring. So an example here would be if this chip overheats due to poor thermal bonding, then system performance and reliability will degrade. Now I know what I have to focus on. I have to focus on the thermal bonding to make sure that the chip doesn't overheat. If the chip overheats, the consequence is system performance and reliability degradation, and I can talk about how much that is. But now we focus on something specific, and I can focus on the thermal bonding. The chip may have other risks related to it, but this is an example of a clear, defined, tangible risk that now has something actionable, which says I'm going to go deal with the thermal bonding to make sure that it's good enough to avoid any kind of overheating of the chip. Now, when we're doing these risk mitigation planning, you have to ask yourself, what are you really doing? Yes, we're mitigating risk, but how? We have to show how risk is being reduced over time. So when we do that, when we demonstrate as an example that a technology meets the performance good, have we reduced the likelihood of occurrence or the consequence of occurrence, or both? I'll tell you now that most mitigation plans only address likelihood. We spend a lot of money proving that we can get 42 femtofarads per fortnight. But this can only reduce the risk so far, because if the consequence of failure is high, then we still have to worry about addressing that. And in many cases, consequence reduction is key for high risks, because typically if you have a high risk, the consequence is going to be significant. And in that case, sometimes it requires a change in the architecture, it sometimes requires changes in backups, sometimes it requires an alternative that you must carry in order to avoid the consequence of failure. As an example, a failed rocket can cause the mission to fail. Therefore, the system needs redundant launches. And indeed, that's what the government plans now. They usually plan for a spare. How does a risk mitigation plan look like? Well, here's an example, and this contains what we think are the necessary minimum set of elements that you need to describe a risk mitigation plan. At the top, on the top left, we see the risk description, and that's where that statement comes in. If this happens, do what you have. But the risk assessment, what is the likelihood? What is the consequence? Oh, by the way, that defines the starting point for the mitigation plan. And if we go over to the risk management plan, we will see how we assessed likelihood and consequence. What were the levels of each? Percentage-wise, dollar-wise, schedule-wise, whatever it is the metric we use for likelihood and consequence, that would be defined in the risk mitigation plan. The results of whatever assessment we did makes this point come out to a certain point in the Rubik's diagram. We have a methodology. In this case, as our example on the previous page, we would focus on thermal bonding. We would look at the thermal bonding, we would investigate various types of thermal bonding, various mechanisms of thermal bonding, whatever it is, to make sure that we got a good thermal bond that achieves the proper connectivity to maintain chip junction temperatures below some limit. And of course, we have the leader. On the bottom, you see a stylized graphic. We show high, moderate, and low in a horizontal format, which is crossed with time. We show key milestones across the top, and you'll see in the black line that there are things that we do to reduce the risk. This shows a waterfall effect. Each one of those staircases, and maybe not even a staircase, sometimes activities don't result in a mitigation. They are part of a later mitigation, but you can see the steps that go along. Oh, by the way, those numbers 1 through 6, I would expect to see some kind of a task in the schedule that says, here's the plan complete. Here's the critical people submitted. Here's the 48-hour facility IT support demonstrated. These would all be things that I would look for in your schedule. On the right-hand side of the graphic is an infamous Rubik's Cube. This is the one that shows how we reduce risk. Notice that step 1 reduces likelihood. Step 2, our claim is that we reduced consequence. So as you can see, as we move through the Rubik's Cube, it corresponds, the 6 dots correspond to the 6 steps in the waterfall chart to the left. This is what we would consider as the minimum requirement for a risk mitigation plan. Your graphic may look different, and certainly your Rubik's Cube may look different. And here is the example of the Rubik's Cube. Once again, if you're reducing likelihood, you're moving vertically. In this case, likelihood is the left-hand axis, consequences across the bottom. If you're moving vertically, you're reducing likelihood. If you're mitigating consequence or reducing consequence, you're moving horizontally to the left, hopefully. The problem with reducing consequence is that you usually need something like alternatives, backups, or parallel paths. They need to be funded. They need to have a decision point on when you're going to stick with your baseline, or is it time to move off the baseline because we haven't got the risk mitigated low enough. So these kinds of decisions and how you move needs to have be in your proposal. If you don't have a good rationale for why the risk is being reduced and how it's being reduced, this may lead to a high proposal risk rating. So if you just arbitrarily move to the left in the diagram as an example and say, I'm reducing the consequence of risk, and the government says, no, you're not, then they're may come up with an assessment that says, you really don't understand risk, and that would result in a higher proposal risk rating, something you really need to avoid. So with that, I'd like to get off the stage and ask if there are any comments. My contact information is here. That's my email address. You could forward any kind of questions to me, or you can type your question and Joe will be the moderator. Joe, back to you.